Okay, morning everybody. Let's go ahead and get started. So today we are going to go ahead and work on the quadratic formula. So we're going to derive that first off as soon as we're done with our warm-up. But as a quick refresher of the main skill to solve quadratic equations, completing the square, we're going to do the following problems and see what happens. So we're going to get in vertex form. We're going to do the same thing we did yesterday. Going to get things in vertex form and then try to find zeros. Also, just two of them today. No big deal. And let's dive right in. Here we go. Number one, you have the function f of x, and it's x to the fifth. Oh, nope, x to the second. You guys aren't quite ready for a fifth degree yet. Minus 5x plus 2. So for the first thing you got to do is, if there's numbers in front of your x squared, get them out. There's not, so that's good. So these two are ready to go. We're going to plug it right into our model for completing the square. B would be -5, so just match things up exactly like it looks. B is -5, then the equation I'm going to replace it with over here is going to have this with -5/2s and -5/2s floating around. So here we go with that. I like to put my bracket just to say this is where I'm completing the square, just in case I factored something out. I'm not, so the bracket is actually unnecessary in this step, but I'm going to do it anyway. So x plus -5/2, that's the same thing as just -5/2. So this b/2 thing is going to be -5/2. And then you have to subtract off what it is squared. So let's go off to the side and figure out what is -5/2 squared. Well, what's it mean to square something, everybody? If I said 4 squared, you just do 4 times 4, correct? Well, if I say anything squared, I hope you think that that means anything times itself. So what is -5/2 squared? Well, this comes down to how do you multiply fractions? Guys, how do you multiply fractions? Straight across. So there's like 3 rules for all of fractions: how to multiply them, how to divide them, and how to add and subtract them. So for multiply, tuck that away, you just go straight across. -5 times -5 would be 25, and 2 times 2 would be 4. So the thing squared, this b/2 squared thing, is 25/4. So that's what I'm going to write right there. And my bracket part is complete now. That is the completing of the square. So the formula has been used appropriately. Don't forget there's other things involved. You were just working on these two things. There's still the +2 on the end. So I still have this +2. And that's what it's looking like so far. Only thing you can really do here is there's no numbers in front to put in or anything. So these brackets, like I said, are kind of pointless. The only thing left to do is I could combine -25/4 and 2. I could put them together somehow. But that requires me to know how to add fractions. So let's see. How do you add fractions? Well, first off, how do you write 2 as a fraction? 2/1, correct? And to add or subtract fractions, the rule is you got to get a common denominator. There's rule 2 of 3. So you have to multiply this on top and bottom by 4. So that makes sense. 2 is the same as 8/4, right? Checks out. So -25/4 plus 8/4, if you add the tops, would be -17. And you don't change the bottoms, 4ths. So that is this thing all cleaned up. It looks exactly like vertex form. This is what you want for vertex. You want something squared. Maybe there's a number in front, some number on the end, and we're good right there. You can get in vertex form like this, then the point of it is you know where the vertex is. H, it says x minus h. This says x minus 5/2. So h must be 5/2. So h is 5/2. K is -17/4. That is the coordinate of my vertex. So where's 5/2? 5/2 is a little more than 2, but less than 3. So halfway between 2 and 3, actually. -17/4. That's a little bit more than 4. 17/4 is a little bit more than 4. It's negative, so it's down. So it looks something like that. That's where my vertex would be. And then, of course, the number in front was a positive originally, so this thing kind of opens up. If you want to get all fancy, there would be that axis of symmetry we studied way long time ago in the first section of this stuff. And that's pretty much all vertex form is good for. I know where the vertex is. I know where the axis of symmetry is. That's great. But what we're really obsessed with in this class is where do things cross this x-axis? Where do they equal 0? So let's find out where this thing equals 0 by saying equals 0. And this whole strategy of completing the square is you can get the squared thing by itself and then do it with the square root. That's what the square root property is. It says that in your homework. Use the square root property. Basically, we're just saying we're undoing a square. But get the square thing by itself. So move the 17/4 to the other side. That way the squared thing is all alone. And then we're going to undo it with a square root. And whenever you take a square root, don't forget your plus or minus. Now over on the left, I'm going to try and do a couple things at once. I'm about to take the square root of 17/4. Is the square root of 17 a pretty number? No. Do any perfect squares go into 17? No. Can't do anything with 17. But 4, is the square root of 4 pretty? Yeah, that's 2. So you can take the square root separately. If I take the square root of the top, I can't do anything with it. It's square root of 17. But on the bottom, the square root of 4 isn't a square root anymore. It's just 2. So that's the best way to write that square root. Square root of 17 on top, just 2 on bottom. And of course, that undid the square on the right. That was the whole point. So you got x minus 5/2 left. And then all you got to do is add the 5/2 over. So x is going to be 5/2, because when you move it over, it's positive. And then either plus the square root of 17 all over 2, or minus the square root of 17 all over 2. So there's my 2 answers. And then you can't do much more else with that. You got a 5, you got a square root of 17. They don't go together very nicely, so we're pretty much done with that problem. And that's quite a lot of stuff there, but if you're getting the gist of that, kudos to you. You can do anything. Let's try it one more time. So number 2 today. This one has a number in front of the x squared, unfortunately. Negative 4x squared minus 12x plus 2. So again, your job is to complete the square just on the part that has x squareds and x's. So we're going to look at these two. But you can't use the formula because the formula has no thing in front of the x's. So you have to factor out this negative 4 from this group first. I don't care what's in front of the x squared. I don't care if it goes in the second one or not. You got to factor it out of both of them. That leaves you a fraction. So be it. Luckily, this time it does not. When you factor a negative 4 out, it just leaves you with a 3. So that's nice and convenient. The mistakes I'm seeing so far, people are doing way too fast. They're trying to factor something out and complete the square all in one step, and that's just going to overload you. All we're doing on this step is just taking the negative 4 out. Now, this stuff inside here, now I will complete the square on it. So b is going to be 3. So I'm going to copy this down exactly like it looks and replace all the b's with 3. So it's going to be x plus 3 over 2, because it says b over 2 in my equation. So I write 3 over 2. Minus, and then it says 3 over 2 squared. So let's figure out what 3 over 2 squared is. Again, squaring something means to multiply it by itself. So looking at that fraction right there, multiplying straight across, what is 3/2 squared, guys? 9/4, dang right. So I'm going to put 9/4 right there. That's what b over 2 squared is, so I put 9/4. Excellent. All right, so we completed the square. Great, that was what the point of it was. Now the point, we took the negative 4 out so we could do that. Now we're going to put the negative 4 back in. So putting the negative 4 back in, when you redistribute it in, make sure it goes to both people. There's a person here, and there's a person there. It needs to get distributed to both of them. This times this, there's nothing you can do with it. Do not try to put the negative 4 in with the x stuff. It's not going to work because the x stuff is squared. So you have just negative 4 times this thing. Now, negative 4 times negative 9/4 is actually pretty easy. Going out to the side, what is negative 4 times negative 9/4? Well, negative 4 is negative 4 over 1, right? If you multiply straight across, a negative times a negative is a positive, right? And 1 times 4 is 4, you get 9. Or alternatively, if you look at this originally, here's a 4 and here's a 4, right? If there's one on top and one on bottom and they're multiplied, they cancel out. Negative times a negative is a positive. So no matter how you look at it, you get just 9. So negative 4 times this thing is a positive 9. And you still got the plus 2 on the end. And the only other thing to do is just put the 9 and the 2 together. So when it's all said and done, your vertex form is going to look like this. F of x is negative 4 times the quantity x plus 3/2 squared plus 11. All right, so what's that tell us about? It's in vertex form. It tells me something about the vertex. Since it says x minus something, this says x plus something, it's not 3/2. It's actually negative 3/2 for h, and k is 11. So at negative 3/2, which is a little bit more than negative 1, And at positive 11, I'm going to be lazy and just put 11 up there. There's some kind of vertex. Does the thing open up or down? If you look anywhere in the equation, there was a negative in the original one, right? So it opens down. So it looks something like this. And again, there's this axis of symmetry right through the middle, like we talked about a long time ago. And that's kind of what it generally looks like. Of course, like I've been harping on, the main thing we're after here, far more important than what the shape of this thing is, where it crosses the axis, where this thing equals 0. So if you set it equal to 0 and move some stuff around, let's see what we can do here. Well, my job is to get this square thing by itself. Let's move the 11 over. It's really got nothing to do with it. So if you move the 11 over, we're closer to having the squared thing by itself. But now the square thing's got a -4 in front. Well, let's get rid of that. -4 times something, we can undo it by dividing by -4. So if you take both sides and divide by -4, then those will cancel out. And on the right, you have -11 over -4, which is the same thing as just 11 over 4, right? All right, so this is 11/4. We got the squared thing by itself. It's time to undo it with a square root. So we're going to take the square root of both sides. On this side, automatically, I'm going to write plus or minus. I'm trying to take the square root of 11/4. So let's just look at the two numbers separately. 11. Square root of 11 pretty? No. Any perfect squares going to it? No. So we'll leave it as just square root of 11. Oh, thanks. Okay. Down the bottom, we had a 4. Is the square root of 4 pretty? Yeah. So I'll just write the bottom as 2, because the square root of 4 is 2. You can take the square of the top and the bottom separately. Nothing wrong with that. And of course, that's still equal to the thing. It was x plus 3/2. We undid that square. And then the only thing left to do is just move the 3/2 over. So in the end, if you move the 3/2 over, it's a -3/2. And then plus or minus this awkward square root of 11 over 2. And those are the exact answers for this problem. And that's kind of all there is to completing the square. It's a tricky skill to get, though. I understand. It's got a lot of skills in there. You got to factor things out. You got to do fractions. Got to be careful. Then you got to understand what it means conceptually. So it's quite a thing. Luckily, I'm not going to have you do completing the square all year. It'll be on your test because it's a good skill to have. I'll try to give you some softball ones. But completing the square, we're doing the same thing every time. I'm factoring out this number in front. I'm taking this thing and dividing it by 2, and then I'm minus this b over 2 squared thing. It's a very systematic, step-by-step. I'm doing the exact same thing over and over again. So if I'm just doing the exact same thing over and over again, couldn't I just do it once for any kind of numbers that might be involved and call it a day? The answer is yes. And today we're going to complete the square and come up with an equation for any quadratic that will solve it, known as the infamous quadratic formula. Very important formula to know. Extremely important. Homework's due today, the first one. If you did it on paper, then needs to be turned into the tray over there. You guys, for the first hour, would be the top left tray over there in the blues. 5th hour would be the top right in the blues, and 8th hour would be the bottom right of the blue trays by the thing. Koi. Yes, you may. So that's due by 3 o'clock always, whether it's online or not. So it needs to be in the tray before the end of the day if you don't want to be counted late. If it's late, I'll dock you a couple points or something like that. And with the new section comes new homework. So take a minute and write it down. 3.5 is due today. That's what I've been harping on. Here's the new one, 3.6. It's not due till Thursday. Is very much practicing one skill mostly, the quadratic formula. There's also something inside the quadratic formula called a discriminant, which can help you identify very quickly what kinds of answers you're going to get out. Are they going to be pretty? Are they going to have square roots of 11 of them? Are they going to be complex? What kind of answers am I going to get out? So this new section 3.6 is about two things, the quadratic formula and the discriminant. Your homework's 3 through 21, multiples of 3. So 3, 6, 9, 12, all that kind of jazz. And then the last section says 24 through 46, and there's an E after it, so make sure you make a note to yourself that that means even. Don't go do the odd ones. That would be a waste of your time. That's not that many problems. It's like, I don't know, 15 or so. That's not unreasonable. And that'll be due on Thursday. Of course, this is always posted on Google Classroom. The problems are on Reveal or on your online textbook. When you log into Reveal, there is a link that says Student Edition ebook. That is what I go off of when I make my lessons, and it's the same thing you see here and on the same exact problem. All right, let's get started. So we are doing section 3.6 today. Here's your title. Using the quadratic formula and the discriminant. First things first, always, what the heck is the quadratic formula? What the heck is the discriminant? So I'm going to complete the square one more time on a very general quadratic, and we're going to prove what the quadratic formula is, and then from now on, you're allowed to use it to solve any quadratic without going through the hassle of completing the square. But keep that skill in mind, because when the test comes, I will have a few problems on there that says solve by completing the square. All right, let's get to it. Here we go. First things first, we need to derive the quadratic formula. So you don't need to write this down, just kind of try to follow along. I'm going to try to write any quadratic down with any A and any B and any C, anything. And I'm going to try to do what we just did. I'm going to try to complete the square. So what's the first thing you do? There's a number in front, right? So what do? You factor that out, correct? So I'm not worried about the number on the end. I'm going to factor this A out. Now, there was no A in the B, correct? So you have to make it a fraction. And if you haven't noticed yet, when you factor something out, you're just dividing by it, right? So if this was a 7, then you took, well, I don't know about 7, but check my distribution. If you put the A back in, what do you get? AX squared, right? And you put the A times here, was the A and the divide by A, do they cancel out? So this is still the exact same thing, just looks a little different. Now, what do we do when we complete the square? We go to our little formula, correct? This time B, this letter B, the number in front, is actually B over A. So I'm going to write all this stuff with B over A's as B's. So to factor this, it's going to be X plus, and that's B over A. B over A divided by 2. When you divide by 2, you just put it on the bottom. So B over A divided by 2 is B over 2A, and that's all there is to that. Minus, whatever that thing is I just made up, squared. Well, what's B over 2A squared? Anything squared, B over 2A means to times itself, which would be B squared over 4A squared on the bottom. So I need to subtract off B squared over 4A squared. So it's a little weird to do it with just letters, but the letters just represent numbers, and we're okay. Now, the whole reason you took the A out was so you could do complete the square, so you're going to put it back in now. So it's A times this thing. I'm doing the same exact steps we'd always do. I'm just doing it with very general things. Now, when you do the A times this, there's one A here, and there's 2 on the bottom, right? So if there's 2 on the bottom, one of them cancels and one is left. So we have this big thing left. Now, just like any completing the square, your job is to get the squared thing by itself. So you're going to move this junk to the other side. When you do, this will be positive, and the C will be negative. So you just moved them over there. And then you have this A times this thing right here. Now I see a fraction minus a fraction, so you need to get a common denominator. If you want 4A on the bottom, you got to multiply this one by 4A. So now it's a 4AC over a 4A. And when you add or subtract fractions, you just do it to the top, so you don't change the bottoms. And we got this thing right here. We're close. We're close. I almost got the squared thing by itself. If you divide by A, remember when you divide by something, just put it on the bottom. So this side here has another A on the bottom. It used to have 1, now it has 2. And you got the squared thing by itself. So how do you undo it? With a square root, right? Take a square root of both sides. So X plus B over A, B over 2A, excuse me. equals, don't forget your plus or minus, the square root of this thing. Now on the top, it's just some ugly stuff, b squared minus 4ac. But on the bottom there, the square root of this is pretty because you can take the square of these separately. What's the square root of 4? 2. What's the square root of a squared? Anybody know that? Square root of a squared? What's the square root of 4 squared? What's 4 squared? What's 4 squared? Oh, wait. What's 4 squared? 16. What's the square root of that? No, square root of 16 is not 2. Ah, what's 5 squared? What's the square root of that? Well, if I say 6 squared, what's the square root of that? What's the square root of that? 6. So when I say the square root of something squared, you just tell me the original number, right? So the square root of a squared is just a. And to finish this thing up, just all for x. If you move this to the other side, then x is negative b over 2a plus or minus b squared minus 4ac all over 2a. But these got the same denominator, so why not just add them together? Ah, look at that pretty thing. That is the solution for this equation by completing the square, just like we have been. And that formula is so darn important that you want to write it down. It's called the quadratic formula. Right there. It comes from completing the square. It's solving things just like you have been. It's a little tricky. Lord knows that took a lot of algebra to get there. But this did exactly what you've been doing on completing the square, just with abstract numbers called a, b, and c instead of concrete things like 6 and 2 and 1 and things like that. And this equation, you just have to plug things into it, and it'll spit out the answers for you. It's so beautiful. And we will keep working with quadratics over and over and over again as the year progresses. So you need to get this formula figured out and memorized. You need to memorize this thing. You are not going to survive if you don't remember the quadratic formula. I'll probably give it to you on the first test. And then the rest of the year, I will expect you to have it committed to memory. What the quadratic formula says, if you have something that looks like ax squared plus bx plus c equals 0, it has to equal 0. Then the solutions are x is negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's very easy to use, provided you plug things in and use parentheses with negatives, raised to powers, and things like that. So it's beautiful. It's nice. Let's go ahead and dive in and do an example. I don't feel like doing that one. It looks boring. Let's do this one. Write down example number 2. No need to complete the square. It's just going to spit it out for us. Oh, man. That's just awesome. All right. So it's just plugging things in, really. The first thing you got to figure out is what does a, b, and c even mean? A is the number in front of your x squared. So what's a, guys? 1. What's b?
4.
What's c? That's it. So we're going to plug them right in, just like it looks. Nice and slow. So x equals negative b. B was 4. So negative 4. Negative 4. Plus or minus. There'll always be 2 answers for this. Just like when you completed the square and had to do a plus or minus when you took a square root. This is no different. There'll always be a plus or minus. There'll always be 2 answers involved. Next comes b squared. Now you can just write b squared, or if you know what b squared is off the top of your head, that's great. B was 4, right? What's 4 squared? Okay, so I'll just write 16. 16 minus 4. There's always this 4. There's always a 4 in there, and there's always a 2. 4, a was 1, right? So times 1. Eventually, I'll stop writing that because writing times 1 is pointless, correct? But I'm going to do it right now just to show you the structure. There's a. And then times c. Now, the signs matter. C is negative, right? So c is negative 17. So I'm going to put in parentheses, because if I don't put in parentheses, it means minus 17. If I put in parentheses, it means times negative 17. And then the bottom goes 2a. Well, a was 1, right? So 2 times 1 is just 2. And now there's a lot of calculator stuff. The first thing you do probably to attack this is work on the stuff under the square root. This stuff under the square root has a name we're going to talk about very soon in this lesson called the discriminant. But right now, just let's worry about the stuff under the square root. So you get your calculator out and type in exactly like it looks. 16 minus 4 times 1 times negative 17, and you see what you get. 16 minus 4 times 1 times negative 17. Let me know what you get when you do all that. I got 84 too. Sweet. So all this stuff under the root turns into an 84. If you didn't get 84, check how you typed it in your calculator. Now, those are fine answers, but can we do better? I see a root. So can we clean up a root? Let's always think about that. Here's some perfect squares. I think 4 goes to 84. Would you agree? Okay. How many times? Anybody know? 21. Okay. So I'm going to break up the 84 into a 4 and a 21. Because 4 times 21 is 84, right? And the reason I'm doing that is because the square root of 4 is pretty, correct? Square root of 4 is just 2. So let's say it's negative 4 plus or minus 2 times the square root of 21 all over 2. And that might look pretty good, but we can do even better. Kind of like with the I stuff, what Reveal wanted you to do is simplify fractions, like simplify this part, simplify this part. What about just the negative 4 over 2? Forget the root stuff. Negative 4 over 2, can you reduce that? What's that? That's negative 2, right? So negative 4 over 2 is negative 2. I have a plus or minus, and then what about the weird root stuff? Well, it's got a 2 on top and a 2 on bottom. Don't those just cancel out? So the only thing left is a square root of 21. So here's your best answer. X is negative 2 plus the square root of 21, or x is negative 2 minus the square root of 21. So it still takes a little work. You got to clean up roots and simplify things a little bit, but it just spits out the answer, which is a lot better than completing the square from scratch every time, which would be horrible. Let's try another one. Here's this one. Write this one down. Let's try it out. Got to complete some squares. All right, so write it down right off the bat. You should be thinking A is 3, B is negative 5, and C is negative 1. Their signs do matter. So here we go. Right to the formula. X equals negative B. Now, what's B? Negative 5? So what's negative B then? If B's positive 5, switch the sign, right? So the negative of it just changes the sign. So if it was negative 5, it's going to be just positive 5. Exactly. So negative B is 5. Negative 5 is 5. Plus or minus the square root of. Now, this is probably where people are going to jack up with their calculators. B was negative 5, right? So a lot of people are going to do this in their calculator. They're going to type negative 5, and then they're going to write squared. That is incorrect. Does anybody see why that won't work? I got to put in parentheses. I cannot emphasize that enough. If you have a negative raised to a power, you've got to put it in parentheses, or else it's going to square it first and then put the negative inside there. So be very, very, very careful about that in your calculator. Right there, that B squared. That's the main thing you need to be worried about. This is minus 4 times A. A was 3. And then times C. C was negative 1. So I'm going to put that in parentheses. Probably a good idea if you just encounter a negative at all, put it in parentheses. And then on the bottom goes 2 times A. A was 3. 2 times 3 is 6. Okay. Let's clean up that discriminant. You know what that means yet? Haven't taught it yet. Just the stuff under the square root. So type that in your calculator very, very slowly. Make sure you put the negative 5 in parentheses. This is really easy if you type things in your calculator correctly. What'd you guys get for the stuff under the root? I agree. I got the same thing. So now I stop and ask myself, okay, can I do better? The square root of 37. 37 is prime. Nothing goes into it. 4 doesn't, 9 doesn't, none of these do. So there's no chance of cleaning this up. And if you can't clean it up and nothing's going to cancel it, can you reduce 5 over 6? No. Can you reduce that over 6? No. So we're done. Let's just call that an answer. X is 5 plus or minus the square root of 37 all over 6. And that's 2 answers again. Remember, the plus or minus means one answer is when you do the plus, One answer is when you do the minus. I'll try this one. Can't do it enough. Sure.
On the last one, we pulled through it 84 apart.
Right.
And why can't we pull through it 37 apart?
Because there are no perfect squares that go into it. So the only chance you have of cleaning up a root is when one of these numbers goes into it. And 4 doesn't go into 37, does it? 9 doesn't, 16, nope. So we tried, but it didn't work. Sometimes they clean up, sometimes they don't. This was a case where it didn't. But always look at those perfect squares. That's the ones that's going to guide you. Good questions, good questions. All right, 5x squared plus 8x plus 11 is 0. Let's see what happens on this one. Here we go again. X equals negative b. B is 8, correct? So that'd be negative 8 plus or minus the square root of. When you get to the b squared, you can probably just always do that in your head real quick. B was 8. 8 squared is 64. And that number there should always be positive. So if it's a negative, you know you jacked up your calculator somehow, because when you square anything, it should be positive. Minus 4 times A was 5, times C, which was 11. And that's all over 2A. A was 5. 2 times 5 is 10. So this is what we have now. And let's clean up the discriminant. By that, I mean the stuff under the square root. 64 minus 5, 4 times 5 times 11. What did you guys get for that? I did too. So there's a negative under my root, which should be a big red flag to you guys that there's going to be an I involved, correct? Negative under roots are I's. In fact, while I'm at it, I can just take the negative out and put an I outside. That's totally okay. Okay, now back to your question. 156, can I clean that up? Well, let's find out. I got to figure out if any of these numbers go into 156. I'm going to start with 4. Maybe 4 does. Does it look like 4 might? I don't know. Take 156 divided by 4. 156, does 4 go into 156? Oh, that's good. It does, doesn't it? How many times? 39. Okay, so I'm going to break the 156 into a 4 and a 39. It's a little better. It's a little better. Because the square root of 4 is just 2. So when I replace the square root of 4 with 2, that's slightly better. Slightly better. Okay, that's pretty good. I think we can do slightly better. Because if I ignore this stuff, how about 8 over 10? Could you reduce 8 over 10? What would that be, like 4/5? And if I ignore this part, what about 2 over 10? Could you reduce 2 over 10? That'd be 5ths too, right? So I can kind of reduce both of them in my head at once. Negative 8 over 10 is the same as negative 4 over 5. Would we agree with that? And then plus or minus, now I can't just change one part, but I got to change the other part. What about the 2 square root of 39i over 10? Well, 2 over 10 is just 1/5, right? So I have a 5 on the bottom and a 1 times square root of 39, or just square root of 39, and then you got the I. So that's the best answer right there. X is negative 4 plus or minus the square root of 39. And if you look at square root of 39, too, you might ask yourself, can I do better? No, none of these numbers go into 39, do they? So we tried, but we cleaned it up, and that's all there is to it. So it's a very tedious process, but it's very straightforward, too. Let's try this one. Can't do enough. Solve 9x squared minus 3x. Plus 18. Always be checking, too, is your equation equal to 0? All the problems I've been giving you are equal to 0. That's great, but they're not. Your first step, of course, like most things, is to set equal to 0 and do it. All right, here goes the formula again. X equals negative b. B was negative 3, though. So negative 3 is positive 3. So negative b is 3. Underneath that square root, the discriminant, b squared, negative 3 squared. You can drop the sign when you square the thing because it's going to be positive no matter what, right? So what's 3 squared? It's 9. So I can just put 9 minus 4 times a, which was 9, times c, which was 18. And that's all over 2a. A was 9. 2 times 9 is 18. So we got this thing. And now we'll go clean up that discriminant, the part under the square root. And it's not pretty. I get negative 639, which while I'm at it, if there's a negative under the root, I can just call it an I outside. 639, oh Lord, what did I get myself into? Let's see. Can we clean it up? 4 doesn't go into it. Does 9? Let's see. 639 divided by 9? 71. Okay, so let's break this up. 71, you tell me. All right, so I can break the 639 into a 9 and a 71. That's helpful because the square root of 9 is pretty. Square root of 9 is just 3. Can I do better, square root of 71? I don't think so. I don't think any of these numbers going to 71. Would you kind of agree? I don't think so either. So that's about as clean as we're going to get with the root. Can we simplify the fractions? I see 3/18 in both of them, don't you? Can I reduce 3/18? Sure, 1/6. So I'm going to change all these 3/8 to just 1/6s. So the final answer will be, there's a 1/6 there, 1/6, 3/18, same thing. Plus or minus this fraction, the 3/18 is 1/6, but I still got this square root of 71, and I still got this I thing. So there's my final answer for that. And as long as you're careful with it, it should be pretty darn straightforward. All right, last thing to talk about today is the idea of a discriminant. You've already been doing it. You didn't know it. Discriminant is a fancy word for the b squared minus 4ac thing, just the part under the root, not the stuff including the root. A lot of students will do the whole square root of b squared minus 4ac. No, it's just b squared minus 4ac. I'll use letter D for it, for discriminant. When somebody says the discriminant, they just are talking about the number under the root, the thing that you've been simplifying the very first thing. So it's kind of like a step back. Really easy to find this. You just do b squared minus 4ac. You don't even do the whole equation. It turns out that what the value of this discriminant is will tell you what kind of answers you're going to get. So I have a cute little cheat sheet for you to write down about what does it mean when you have a discriminant be positive, or what does it mean when your discriminant is negative or 0 or anything like that. And that's really all I want you to understand about the discriminant stuff is if it's positive or if it's negative, what kinds of answers will I get? Will I get I stuff? Will I get clean fractions? Will I get ugly square roots? What kind of things am I going to get? And here's your little cheat sheet for it. So I would copy down the box to the right first off. I'm trying to consolidate all their weird crap into a nice, distinct little note over there. If you're doing the quadratic formula, or before you even do it, if you just find the discriminant, just the b squared minus 4ac part. If the discriminant is positive, that means you're going to get out a couple real answers. Maybe they're 5 and 6. Maybe they're square root of 11 and 2, but they're real. There's no I stuff. And they will be distinct. The key word here is distinct. They will be different answers. You will not get 4 and 4. You will get maybe 7 and 8, 9 and 11. 2 different real numbers on the real number line will occur when your discriminant is positive like that. If the discriminant is positive, then there's other things to consider. You're going to get out a real number, you're going to get a couple of real answers, but what kind of real answers are they going to be? Rational? By that I mean a fraction. Can you write as a fraction? Or are they going to be irrational with weird square roots in them? Square roots of 3s, square roots of 17s, weird stuff. If the number you get out is a perfect square, because remember this is under the square root, right? So if you get out like 36 under the square root, is the square root of 36 pretty? Yeah. If you got out 49 under the square root, is the square root of that pretty? Yeah. So if the thing under the square root is pretty, or is a perfect square, 9, any of these things in this column right here, if the thing under the square root is any of these numbers, 4, 9, 16, 25, 36, etc., then the square root of that number will be pretty, And it turns out it can be a perfect fraction. And the fancy word for fraction is rational. So if it's a perfect square, it'll be real, and you will get out normal numbers that you like. Pretty things, 4/5, 9/2, something like that. No weird roots. On the other hand, if the discriminant, the thing under the square root, is not a perfect square, like you got out 11, or you got out 5, or you got out 38, or something that's not on this list, then the solutions will be irrational there. So that means that something cannot be written as a fraction. Something that goes on forever and their decimals never repeats. An irrational. When that happens, you can expect your graph to look like this, by the way, this top one right here. It will cross at two distinct things on the real axis. Maybe they're rational, maybe they're not, but that's what's going to occur. When your discriminant equals 0 exactly, that tells you one thing. There's going to be one real, but it's going to be repeated. That means it's going to be there twice. For example, something like that might factor like this. What's the answers to this, guys? What makes this true? 2. What about this one? 2. It's the same answer, right? You only got one answer, but it's repeated. It's there twice, correct? And that's what this one is saying. So when you get one real repeated rational 0, something would factor, it must factor something like this, and you must get out 2 of the exact same answers, but that's the idea. When your discriminant is less than 0, negative, remember this is the stuff under the square root. So if you got out something negative under your root, what would happen? It'd be imaginary, wouldn't it? There'd be some kind of real part and some kind of imaginary part. It'd be complex. So when that happens, you're going to get 2 complex, distinct conjugate zeros. They're always going to be conjugates of each other, which is cute. So how can you, back to the one real one, how can you only have it touch the axis in one spot? It must bounce right off the axis. See how it just bounces off the axis? Doesn't go through it, right? This one goes through it in 2 spots. Would you agree? This one's when D is more than 0. This one only hits it in 1 spot, right? That's when D equals 0. And if there's 2 complex zeros, well, those aren't real. You're not going to really see them. So you will see it cross at no spots right there. So that's how you're going to do this stuff. And let's just do one quick example and we'll call it a day. All right, this one right here. Negative 5x squared plus 10x minus 15 equals 0. So we're just trying to find the discriminant. The discriminant is just the stuff under the square root, just the b squared minus 4ac part. That's it. So if you look at our equation, b would be 10, correct? So what's 10 squared? 100, check. Thank you on that. So there's my b squared. And then minus 4ac. So minus 4 times, the same thing we've been doing, minus 4 times a, which is negative 5, times c, which is negative 15. And you're going to get out a specific number here. There's going to be some random number. 100 minus 4 times negative 5 times negative 15 is negative 200. So if you do this analysis, go back to your little cheat sheet right now, and all they want you to do about this is tell me what this means. What kind of answers would I expect from the quadratic formula if I got this? Well, here's your discriminant. It's negative 200. That's less than 0, right? So your answer to this is to blindly kind of copy down what this says. That means that there's 2 complex, distinct, different conjugate zeros. Write down that line. Basically, you're going to figure out which one this is and write it down. That's your answer. This implies there's 2 complex conjugate zeros. And if you did the quadratic formula all the way through, that's what you would get. You'd get out 2 complex numbers. Some of it's real, some of it's got some I stuff. They'd be conjugates. Remember what conjugates mean? Maybe one would be 4 plus 5i. Guess what the other one would be then? 4 minus 5i. Outstanding, yeah. So that's the kind of things I would expect if I did the whole quadratic formula, but I'll let you figure that out in your homework right there. So that's enough for today. Just remember, if they ask you what the discriminant means, look at your cheat sheet right here, look it up, and write down exactly what the ramifications of it are. That's all for today. We'll practice some of that in the warm-up tomorrow. Get cracking on it tonight. 3.6 quadratic formula and the discriminant.